Hi and welcome. So this time around I have some other parts. I got to make another part. He wants 5 of them for another customer. This is a blown up drawing and it's made out of Delrin. Everything's really simple except these 30-degree grooves. Walls have to be fairly accurate. And I'm not sure exactly how this fits, but it's part of a record player. This is a scale drawing, so this is a 1-to-1 drawing of the parts, so they're fairly small. But these grooves are fairly deep and fairly close together. 30-degree walls. So what I'm going to do is grind a 30-degree tool. I've got some high-speed steel here, and I have not got a ton of experience grinding bits, and I'm not going to try and freehand this. Now the nice part is that this bit's already got a slope on the front here that slopes back away from a point, so that saves me one of my grind angles. So let me just give my 2 cents for someone who's very inexperienced about grinding tools. But the general theory is that if you were just going to cut on, say, this far edge over here, you want the tool to fall away in every single direction from that point. Means you want this plane here to slope back. You'd want the top to slope down. You'd want this to slope away back to the side. You'd want this to slope down the way it is right now, and you'd want this corner to slope back like this. You know, this angle. Basically, you want the tool to fall away from the edge at every possible angle. And that would be a normal approach. However, this tool is going to be a 30-degree cutting tool, and so what I'm going to do is I am going to use this angle as relief on that direction, and I am going to grind this side down 30 degrees, this side down 30 degrees, and then I'm going to take the top and put a relief this way on it so that the chips have somewhere to curl. We'll see how successful I am. I got this guy on eBay, and when I got it, this was all painted, and I took it to my surface grinder and ground 2 sides square to each other so that I have a reference point, and I set this at 90 right off the bat so that I'd have somewhere to go from. And then I surface ground the top. These holes were all in here except for these 2 pins. I don't know, there's some sort of weird thing that went on here. And interestingly enough, when this thing's all set to 0 with everything set to 0, this was at quite an angle on here. So some sort of specialized thing. So I squared this up again on the surface grinder, first with the mill and then on the surface grinder. So this is all nice and square. Parallel, this is parallel to these 2 edges here, so when I set up my surface grinder to grind this tool, it should be good. I added these 2 pins because I don't really have a fixture to hold anything down here, and this goes down, slides down. This was to prevent it from tilting too much. It doesn't completely prevent it, but it does an okay job. So 2 bolts go in here, and you tighten them down. So in the meantime, I'm taking a can twist to tighten this side down at the same time. I know you'll see in the background here this Wilton vise. This is a multi-angle Wilton vise that I just got. I still need to build a base plate for it, and I didn't think I'd have it in time to do this. So the quality is okay, not great, certainly not equivalent to what you expect when you pay the Wilton price. Although this wasn't terribly expensive, but it's a really small vise. These are 2-inch jaws, but they didn't even bother deburring where they ground these edges here, which is really strange. You expect more out of Wilton because, again, they're the supposedly, you know, the big name with the high, you pay the high price for them. So a little disappointed in that. The action of the jaws is smooth, so I'll use this maybe for the next tool bit I grind. But in the meantime, we're going to take this guy over to the surface grinder and grind this bit. Alrighty, so here we are with the surface grinder, and I've got myself set up here. And this clamp is just to make sure that this piece is held in here nice and tight because these 2 tend to cant this a little bit. I've got 2 parallels off the back fence that's square to the table, and then I've got the reference surface on the front of the vise. This guy is set to 0 degrees over here. Now I've got this one set to 30 degrees, which is going to give me my 30-degree taper there. And then I also have it tilted slightly this way by about 5 degrees to give me some relief along the side so that it falls away from the cutting point. So we're just going to take some material off and see how we do. Alright, so we're just touching off here. Oops. This new camera holder I've got is going to work out, but we'll see. And this is a cobalt bit. I hope you can hear me. This is a cobalt bit, so I'm going to wear a mask because you don't want to breathe cobalt. Probably would have been easier to take off the majority material on the normal grinder and then come over here and finish it off. But I wanted to try this out. I went back and took most of the material off at the grinder, and then I realized I had done 30 degrees, but what I really need was 15 degrees. I need half angle. So I got to take 15 degrees. I got to go to 15 degrees on each side. So that'll leave me a final angle of 30 degrees. So I took off most of the material. By hand. I don't think you can see this when we pull this out a little bit. So we're going to do the back relief on the cutter on the top now. So we're going to touch off about a little over ½ inch back, which is where we want to have the cutter start. Alrighty, so I got my tool bit on the optical comparator, and you can see that I made the end square. I didn't bring it to a perfect point, and I was wondering how wide that is, just to make sure I didn't have to go back and regrind. And so if you take one edge and set it over, and then hit your 0 over here, and then move until the cross is on the other end there, it's about 22 thousandths, 21.5 thousandths across. And then I'm going to use this to measure the angle. It doesn't have the digital angle measurement option, but I can use the scale on the glass, and when I measured it's 31 degrees. So I think that's close enough for what we're doing here, and we are going to go over and try and make the parts. So let's do a test cut with the new tool, see how she works. So the farthest we'll have to go in is under 200 thousandths. This is essentially a form tool, so let's see, that's 50 thousandths. That's 120. So far, so good. It's 150. Okay, and then I need to go over 30 thousandths, well, 28 thousandths. Okay, that worked like a charm. Better than I expected. First tool second tool I've ever done, but first form tool. And so we got 30 degrees. The side needs to be deburred, but I'm really impressed with how that turned out. Let me part this guy off, and we'll try and actually make the part. The diameter has to be reduced from what its current diameter, which it should be around an inch. This should be nominally an inch. Let's see. .011. we've got to take it down 30 thousandths. But let me just part this guy off. And this Delrin just cuts like a dream. It's pretty fantastic stuff to work with. We'll just part it off right next to that. Normally with the parting tool you don't get a great finish. With this one, with this material, parting tool leaves a pretty nice finish. That's what you're looking at there. Even at this speed. That's a pretty nice finish, huh? All right, so we got to take the diameter down. I'm going to get a mic so we can take a look at that. We're going to take a first pass. We're going to try and leave about 10 thousandths. I do need to slow the feed rate down because that's not the perfect finish we want. So I slowed the feed rate down quite a bit. And we're only taking off 4 thousandths this pass. This might not be ideal. A lot of times with these inserts, it's better if you take a bigger bite. Small bites sometimes don't work out so great. All right. Finish is decent, not perfect. I have seen better with Delrin. I think bigger bites. This really tiny bite, 4/1000th of an inch, is not ideal. Oh, and my insert. I should have rotated to a perfectly clean edge on the insert. The insert's not great either. So these are positive rake inserts. You can see they've got a coating on them to make them very shiny, but you can see the edge where I've been cutting aluminum with it is probably got a little bit of aluminum adhesion, even though the coating's supposed to prevent it. And so I could have gotten a better finish if I had flipped the insert around. Alrighty, but this will be the first part. Let's just see if we can get this guy here. So the end is 22 thousandths wide, so I'm just going to find my 0 here. There's my X0, and I'm going to pull back just a touch. So I'm going to try and find the right edge of this guy, and the way I'm going to do that is I'm going to use a Pajcinski method, which is to use a razor blade. Let's see when I can just grab it. We're going to call that 0. So since this is 22 thousandths wide, what I want is the center line of this. So we're going to come back 11. That makes the center of the cutter, right along the edge now. So the first groove, the center, which when I redid the drawing, let's see if you can see this. When I redid the drawing, I based everything on the center of the groove. So the width of the grooves are 50 thousandths, and the spacing's 50 thousandths. If I remember right, I'm going to have to go double check that. If I remember right, this is the center of this, well, the center of this groove is 101 thousandths over, and call it 102. And I think the width is 50 thousandths on both of these for the base, but I got to go double check that. I didn't get that on this redone drawing. Alrighty. The bottom of the groove is 50 thousandths. The width of the cutter is 22 thousandths. I've created a separate 0 reference for the middle of this part. And what we're doing is we're going plus or minus 14 thousandths either side. So to get the cleanest edge, I'm going to plunge 14 thousandths on either side, and then I'll sweep across to do the bottom, just clean up the middle section. So we are here, and we've got our 0, so we're going to go in to the final depth of 174. And I'm going to come back out and clear the chips. I'm going to go 14 thousandths on the other side. Should leave my bottom to be the final 50 and just plunge down. And that should be the first one. So it looks like a little bit of plastic got turned up here. Hopefully that'll clean up pretty well. Oh, that's the little center ridge I'm seeing. Oh, look at that. Okay, so we'll go find center and we'll just go in the 174 and we'll clean that up. Okay. Now I'm just going to need to deburr this and then pull the little ring out. There we go. Okay, this next groove is only 65 thousandths deep, but still 50 thousandths wide. And we should be done. Just need to deburr it. Second to last stop, pair of ops, drill and ream. Stuff cuts like a dream. However, if I let the chips clog in there, they could melt. So that could be bad. That's drilling. And ordinarily reaming is a very low speed operation, but I think I'm only taking, this drill bit was only 3 thousandths undersized for the ream hole, and I don't think it's going to matter because it's plastic. I might be wrong. That's it. There's the .185 pin. It's a piston fit. Now it's got a vacuum behind it and it doesn't want to come out. All right, so that the whole size should be good. I think this is going to be convenient because normally I would leave extra material, turn around and reface the part, but this is cutting so cleanly. I'm just going to try and part it off and use it as is. We're going to get it to exact size. So final dimension, I've got the edge of the parting tool right on this edge here. And I didn't use the same method, the razor blade method, just used a different one. Basically got this side on a piece of shim stock, just let it just slightly grab, go over 21 thousandths for the thickness of the shim stock, then go over for 77.5 thousandths for the thickness of the cutter. And the final size, length is supposed to be 0.9 even. We're gonna leave it just a tiny bit large. And as long as I'm here, just going to touch deburr that edge. And we are good. So this part turned out great except for one minor problem. If you can see on this drawing, I've got depths here 0.065 and 0.174 and the radial distances, and I forgot that my DRO measures in diameter, so I've actually got to double those numbers. So these depths are half, and when I put this on the one-to-one drawing, I could tell that they weren't going as deep. So we're heading back in, we're making another part. I can actually re-groove these, but I got to change chucks to have a different chuck to hold this and still work on it. So I'm just making another part because it's pretty fast, and I'll be right back. Alrighty, so here's the two parts I made and the test piece I made up here just to see if the cutter worked, which it does. The first one, I only went half depth because the measurements I have here are radial and the DRO was measuring diametral. So I went and remade it and now it lines up much better. Everything is looking really good. So there's the final part, and it's for a record player, and I'm not sure quite where but the customer said he may want 4 or 5 more if this one works out. So we'll see. Thanks for watching. Hope you find it useful. Hope to see you next time.